Hey, and welcome to the lesson where we'll be introducing logarithmic equation. What is a logarithmic equation? We're going to find out in this lesson. So at the end of the lesson, you should be able to introduce logarithmic equations and interpret properties of logarithmic equations. This is a logarithmic equation. So this log is a type of function. And we'll explain its relationship to exponents, and we will explain exactly what it's used for in a later lesson. But right now we're just going to explore logs. They have a common base, which is b. So the way we read this is y equals log base b. So that's usually going to be a number. So that's b could be 2, 3, 10. If you don't see a number there, if you just see, say, log x, it's assumed that the base is 10. Most counting and stuff, most math is done in log base 10, so that's the most popular. Another popular one is is log base e. Now e is a certain number, it's an irrational number. I believe it's like 2.67 something, but it's a number that has a special relationship with logarithms. So log base e is what we call the natural log. Okay, it's also written as ln for log natural log. So if you see like ln x, it's the natural log of x, and we'll get more into that as we talk about logarithmic equations. Some properties for logarithmic equations. So if I have log base a of m times n, I can break that up as log a m plus log a times n. If I have log base a of m over n, I can break that up as log base a times m minus log base a times n. Now, this is also true the other way. If I have log base a m plus log base a times n, or log base a of n, then I can rewrite that as log base a of m times n. If I have log base a of m minus log base a of n, I can rewrite that as log base a of m divided by n. Log base a of n to the k, I can take this exponent and I can write it as a coefficient. Same as if I had the coefficient, I could take that and put it as an exponent. Vice versa, that works too. Log base a of the square root of n. Now, if you think about this, this is also n to the 1 over k. So just like the property above it, you can take that and put it as a coefficient like you have over here. And again, you can also go the other way and back to what you started with. So let's just start here. This is just an example of how you can use the property. So log base 3 of 2x. Well, I can rewrite that as log base 3 of 2 plus log base 3 of x. So those are your properties of logarithms. Sorry, I've been calling them logs. Log is a shortened name for logarithms. So you don't have to say that big long name. So they're called logs. So the log function, there are some properties of it. If you have any questions on your homework, go ahead and get started on that. If you have any questions, reach out to me. Love to help you. Hope to see you in live class where we can talk about this some more and answer some more questions for you. Meet me in the Math Cafe if you need any help, Monday, Tuesday, and Wednesday at 11 a.m. If that doesn't work for you, there's teachers in there every day from 9 to 3 that are willing to help you out. So if you need help, please go there. I mean, you can still come to me, but I'm saying that's a great resource for you. And so, things to remember. The properties of logarithms, they're on your right, but notice the striking resemblance to the properties of exponents. So the product property, b to the m times b to the n is the same as b to the m plus n. Well, that seems very, very familiar to this property, and so on. So take a look at that. Definitely copy this chart now. It will come in very, very, very handy. You're going to want to remember these tips and tricks to help solve problems in upcoming assignments. And then think about them, look at the similarities, and get ready for our next lesson, which will be logarithms as inverses.